motion in a straight line. Okay. As we know that each and every object around us may be at rest or at motion. Okay. Maybe at rest or at motion. What is the branch of physics which deals with the conditions for this rest and motion? Yes, it is mechanics. 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 Mechanics is a branch of physics that deals with the conditions for rest and motion. This mechanics is classified into two branches. One is statics. Statics. And another one is kinematics or dynamics. Dynamics. Statics is a branch of mechanics. Statics is a branch of mechanics which deals with the conditions for rest or equilibrium. So kinematics is the branch of mechanics which deals with the conditions for motion. This also, dynamics is also the branch of mechanics which deals with the conditions for motion. So here, the cause of the motion is not considered. In kinematics, the cause of the motion is not considered. Cause of the motion in the sense, yes, force is not considered here. Okay. In dynamics, cause of the motion is considered. That is, force is considered. Okay. That is the difference between that is kinematics and dynamics. Then what is rest? What is rest? An object is said to be at rest if it does not change its position with the passage of time. If it does not, an object is said to be at rest if it does not change its position with the passage of time. So what is motion? Motion. An object is said to be at motion if it changes its position with its surroundings with the passage of time. Okay, with the passage of time. So here in this chapter we are full and fully concentrate about that is motion. Okay. So there are three types of motion. That is one-dimensional motion, one-dimensional motion, two-dimensional motion, and three-dimensional motion. Next we are going to discuss about that is what is one-dimensional motion, what is two-dimensional motion, and three-dimensional motion. Consider the Cartesian coordinate system. Consider the Cartesian coordinate system, which consists of three axes, right? This is the z-axis, this is the x-axis, and this is the y-axis. This is the origin. Okay. A particle or object at this position. So at this position. So P is a particle at this position. How we can represent this, the position of this object, that is P of x comma y comma z, where x, y and z are the distances from the origin along the x-axis, y-axis and the z-axis respectively. Okay, so x is the distance in the x-axis. Okay. So this is the distance in the y-axis, that is y, and this is the distance in the z-axis. Okay. Then what is one-dimensional motion? One-dimensional motion. One-dimensional motion. An object is said to be at one-dimensional motion. One-dimensional motion, that is the any one of the coordinates. Out of these three coordinates, if any one of the coordinates changes with the passage of time. So one-dimensional motion is nothing but that is motion in a straight line. Motion in a straight line. Motion in a straight line. That is called one-dimensional motion. An object is said to be at one-dimensional motion means if any one of the coordinates out of these three coordinates, it may be a x-axis or y-axis or z-axis, changes with the passage of time. So one-dimensional motion is nothing but that is motion in a straight line. So example for one-dimensional motion, that is a train moving in a straight track. Train moving in a straight track. 2. A freely falling body. Freely falling body. Freely falling body. That is on a body is falling from a certain height under the action of gravity. So, okay. So that is also considered as one-dimensional motion. Then what is two-dimensional motion? What is two-dimensional motion? An object is said to be at two-dimensional motion if any two of the coordinates specifying the position of the object changes with the passage of time. So, okay, two-dimensional motion. Two-dimensional motion means motion in a plane. One-dimensional motion means motion in a straight line. Two-dimensional motion means motion in a plane. So what is an example for two-dimensional motion? That is one projectile motion. Projectile. All the projectile motions are example for two-dimensional motion. That is both the x and y values are changing. Then 2. A car moving in a zigzag manner. Okay, zigzag in a level road. In a same level road. Okay, that is also considered as a car moving not in the straight line. It is moving in a zigzag manner in the same level road. That is also considered as two-dimensional motion. So the next is three-dimensional motion. Three-dimensional motion. Three-dimensional motion. An object is said to be at a three-dimensional motion if all the coordinates that is x, y and z changes with the passage of time simultaneously. So that is called a three-dimensional motion. Three-dimensional motion means motion in the space. Motion in the space is called a three-dimensional motion. Okay. So what is an example for three-dimensional motion? One aeroplane moving in the sky. 2. A kite flying in the sky. So these are the examples for three-dimensional motion. So these are about different types of motion. So the next very important topic, that is distance and displacement. Distance and displacement. So first we are going to say, that is distance. The total path length traversed by the body from the initial point to the final point is called distance. A distance traveled by the body is called, that is the total path length traversed by the body from the initial point to the final point is called the distance. Okay, suppose this is the point A, B and C. An object starts from A and reaches the point C through B. So what is the distance traveled by the body? So distance equal to, that is AB plus BC. AB plus BC. That's why I told, that is the total path traversed by the body from the initial point to the final point is called the distance. Okay. Characteristics of displacement. Distance. Characteristics. First point, it is a scalar quantity. So we will discuss about, that is the vectors and the scalars in very detail in the next chapter. So okay, for the time being, you just understand that is, in physics there are two types of quantities, that is scalar quantities and vector quantities. Scalar quantities means it have only magnitude, no direction. So the vector quantities means both magnitude and direction. So here, so that is the distance is a scalar quantity. Scalar quantity means that is magnitude. Okay, magnitude, no direction. 2. Distance traveled by the body is either 0 or positive. So there is no negative distance. So we don't represent the distance as a negative quantity. Okay. So 0, that is an object is at rest. It is not moving anywhere. That is the distance is. So in this case, the distance traveled by the body is 0. So otherwise we will say that is the distance traveled by the body is plus 5 meter, plus 20 meter. Okay, like that we will. That's why I told, that is distance may be 0 or positive. Then 3, SI unit of distance, that is meter. 4th one, that is CGS unit, that is centimeter. So SI unit of distance is meter, CGS unit of distance is centimeter. So the different types of distance system of units and measurement, that is the first chapter. So we will cover all the chapters in physics and we will come back to the first chapter. Okay. So the first chapter we will discuss, that is the units and measurements. So different system of units we will discuss in that chapter. Okay. So for the time being, that is SI unit is meter and the CGS unit is centimeter. Okay. So these are about distance. Next is displacement. Displacement. Very, very important quantity, that is displacement. So displacement is the shortest path from the initial point to the final point. In a journey, the shortest path from the initial point to the final point is called displacement. Or we can say the straight line path from the initial point to the final point is called displacement. So consider the previous case. That is this point A, this point B, this point C. Okay. An object is initially at the point A, finally it reaches the point C. So it travels through B. Okay. So what I told, that is in distance, that is the distance traveled by the body is equal to, that is AB plus BC. But the displacement, what is the definition? The shortest path between the initial point and the final point. Or otherwise, the straight line path between the initial point and the final point is called displacement. So displacement is equal to AC vector. AC vector. Then characteristics. Okay. The first point, it is a vector quantity. So the displacement has both magnitude and direction. Vector quantity means magnitude and direction. What is the meaning of that? That is displacement, distance we have to say, that is 5 centimeter. That's all. 5 centimeter. So displacement means 5 centimeter towards north. So we have to clearly mention the direction also. It is 5 centimeter towards north. That is called vector quantity. Okay. So 5 means magnitude and this is the direction. Then 2. Displacement may be 0, negative or positive. Displacement may be 0, negative or positive. That is the second characteristics of displacement. Okay. So I will explain how it is 0, that is negative or positive. Case 1. This is the origin. The body is, this is origin. Initially the body is at A. Okay. So this is the distance x1. Okay. The body A travels to the point B. The point B, which is at a distance, x2. Okay, x2. So what is the displacement of the body? This displacement is equal to the shortest path between the initial point and the final point. So displacement is equal to, that is, x2 minus x1. Okay, the displacement traveled by the body. So this is the displacement. That is the shortest path between the point, that is initial point, and the final point. So how we will get, that is x2 minus x1, which is definitely greater than 0. Okay, greater than 0. So in this case, the displacement is positive. Displacement is positive. Okay. Then case 2. This is the origin. Initially the body is at point A. Okay, A, which is at a distance x1. The body travels from A to B, which is at a distance x2. It's at a point x2. So in this case, what is the displacement? So displacement, that is, displacement is equal to x2 minus x1. So which is less than 0, that is negative. Okay, negative. So the displacement in this case, that is negative. Then case 3. So this is the origin. Initially the body is at A, which is at a distance x1. The body travels from A to B and returns back. So finally the body is at A, which is also the distance, that is x2. So what is the displacement here? So displacement is equal to x2 minus x1. So which is equal to 0. So in this way, that is, the displacement is 0, negative, or positive. And third one, the SI unit is meter. Fourth one, CGS unit, that is centimeter. Okay, these are the points regarding the displacement. So some more conceptual questions, that is, is there any possibility of displacement greater than the distance traveled by the body? Never. Okay, so displacement always less than or equal to distance. Okay, it may be less than the distance or equal to the distance. It's never greater than the distance. It is a very important point. Okay, displacement less than or equal to distance. If the displacement is the second one, that is 2. If the displacement is 0, is it the distance necessarily be 0? My question is, if the displacement is equal to 0, then what about the distance? Is it necessarily be 0? That is, the distance also necessarily be 0? No. So, how we can say that? So, consider a circular motion. Okay. An object starts from this point and completes one complete revolution. Complete revolution. So the displacement traveled by the body, displacement is equal to 0. But the displacement traveled by the body is 0 because the distance between the initial point and the final point is 0. That is, displacement is equal to 0. But the distance traveled by the body is equal to, suppose r is the radius of the circle. So that is 2 pi r. So here displacement is 0, but the distance traveled by the body is equal to 2 pi r. So we can't say that if the displacement is 0, we can't say that the distance is also equal to 0. Okay, that is also very important. So problem number 1. An athlete runs 3 rounds in a circular track of radius 50 meter. Radius 50 meter. What is the distance he covered? What is the displacement he covered? Okay, an athlete runs 3 rounds in a circular track of radius 50 meter. Radius 50 meter. So we have to find what is the distance he covered. Distance equal to question mark and displacement equal to question mark. Okay. So listen here. This is the circular track of radius 50 meter. So this is the point A. From this point the athlete starts running and he completes 3 rounds and he reaches the same point. Okay. So what is the distance he covered? So when he complete 1 round along the circular track, the distance he covered is equal to the circumference of the circle. Right? Circumference of the circle. That is nothing but 2 pi r. Okay, 2 pi r. So if he covers 3 rounds, then the displacement he covered is 3 into 2 pi r. That's equal to 3 into 2 into what is the value of pi? That is 3.14 into what is the radius? That is 50. Okay. So that's equal to 3 into say 6. That is 300 300 into 3.14. So 3.14 into 3 is 2, 4, 9, then 20, then 3.14. Okay, the point here. So that's equal to 942 meter. So this is the distance he covered. So what about the displacement? Displacement, he starts from this point and reaches the same point. After completing 3 rounds, he reaches the same point. So that according to the definition of the displacement is the distance between, that is, the starting point and end point. So the start point and end point is the same. So the displacement he covered is equal to 0. Displacement equal to 0. Okay? Okay. Then problem 2. A man walks on a semicircular track of radius 40 meter. Radius 40 meter. Okay, radius 40 meter. If he starts at one end and reaches the other end, what is the displacement he covered and what is the distance he covered? Okay, this is the semicircular track. Okay, semicircular track of radius 40 meter. So what is the, so we have to find distance as well as displacement. Okay? So distance means that is a semicircular track. One complete revolution means, that is, circular track means distance is 2 pi r. So here distance equal to half into 2 pi r. That's equal to pi r. That's equal to 3.14 into 40. That is, the radius is 40 meter. 6, 5, then 12, and 1, 0. So 2 places. That is equal to 125.6 meter. 125.6 meter. This is the distance he covered. So what is the displacement? Displacement is the straight line path from the start point and end point. Okay? So this is the displacement he covered. So this is the center point. So this is R, this is R. So displacement is equal to 2R. So this is equal to 2 into 40. That's equal to 80 meter. Displacement is equal to 80 meter. Okay? Then problem 3. Problem 3. Consider a clock in the shape of a circle. In the shape of a circle. Consider the movement of the minute hand. Consider the minute hand. In 1 hour, how much distance it will travel? In 1 hour. In 1 hour, how much distance it will travel? How much displacement it will travel? Okay. So distance means distance covered by the one complete revolution. So that is the distance covered by the minute hand in 1 hour. So distance covered by the minute hand is equal to, that is yes, circumference of the clock. Circumference of the clock. That's equal to, suppose R is the radius of the clock. So that is 2 pi R. 2 pi R. Okay. Displacement. Displacement is equal to the minute hand starts from here and again reaches the same point. So displacement is equal to 0. Displacement equal to 0. Problem number 4. A man walks 50 meter due north, 40 meter due east, 20 meter due south to reach his field. What is the distance he travelled and what is the displacement he travelled? Okay, so the direction we are using like that. Okay. Yes. This is north. This is south. This is east. And this is west. A man, this is the starting point, suppose. From here, he walks 50 meter. 50 meter due north and 40 meter due east. 40 meter due east and 20 meter due south to reach his field. So what are the things we have to find? So we have to find the distance he covered and displacement he covered. Okay. So distance equal to, suppose this is the origin O, this point A, B and this is C. Okay. So distance he travelled is equal to OA plus AB plus BC. So that's equal to, what is OA? That is 50 plus 40 plus BC, that is 20. So 90 plus 20, that is 110 meter is the. So what is next step we have to find? That is the displacement he covered. Displacement is the shortest path from the starting point to the end point. Starting point to the end point. Okay, so this is the displacement. Okay, so this is 50 meter totally. So this is 20 meter. Okay, so what about this distance? That is 30 meter. So this distance is same, that is, this is 40 meter. So definitely this is also 40 meter. So this is the distance we have to find. So this is a right angled triangle. So this is the hypotenuse, hypotenuse. So displacement he traveled is equal to OC, right? OC. So OC is equal to square root of 30 square plus 40 square, right? That's equal to root of 900 plus 1600. Okay, 1600. So that's equal to root of 2500. That's equal to 50 meter. 50 meter. Clear? The man starts from a point and walks 50 meter due north, 40 meter due east and 20 meter due south in order to reach his field. So what is the distance he covered and what is the displacement he covered? So distance is nothing but OA plus AB plus BC. That is the path he covered. The distance he covered. And displacement is the shortest path from the initial and final point. So this is the displacement. So displacement is equal to OC. So this is a right angle triangle. So this is the Pythagoras theorem, apply Pythagoras theorem, that is OC equal to 30 square plus 40 square. So 900, 2500, so 50 meter. Clear? Okay. Next problem. So P5. Suppose this is a circle of radius r. An object starts from this point and reaches this point. Okay, that is 1/4 of the circle. 1/4 of the circle. 1/4 of the circle. So we have to find the displacement traveled by the body. Displacement traveled by the. So this is the center of the circle and this is the point. So the displacement means the straight line path from the start point and end point. So this is the displacement. This is the displacement, right? So this is R, this is also R. So this is the origin. Yeah. Okay. So this is a right angle triangle. So displacement is equal to yes, OA. So OA is equal to root of R square plus R square, that is equal to 2R square, that's equal to 2R square. So root 2R. Root 2R is the displacement. Okay, suppose initially the object is at O, it travels to the point A, that is 1/4 of the circle. What is the displacement covered by the point? So the displacement is the straight line path from the start point to the end point. Suppose R is the radius of the circle, this is R, this is also R. So displacement is equal to OA, that is the right angle triangle. So OA is equal to R square plus R square, that is 2R square, that is root 2 R. Then problem 6. Problem 6. Consider a circle of radius R. Radius R. Okay. An object is initially at this point and travels through the circle to the point. This is A, this is B. Okay, this is B. That is half of the circle. Okay, half of the circle. Half of the circle. Okay, what is the displacement in cover? So displacement is this distance. So this is the center of the circle. So this is R. This is also R. Okay. So displacement we have to find. Displacement is equal to question mark. So displacement is equal to yes R plus R, that's equal to 2R. Displacement is equal to 2R. Then the next problem, that is P7. Problem number 7. Consider a circle of radius R. Okay, radius R. A is the point here. So B is the another point on the circle here. An object starts from A and travels to the point B. So what is the displacement? What is the displacement from A to B? Displacement from A to B. This is the center of the circle. So this is radius capital R. This is also the radius capital R. Also it is given the angle between these two radius vectors, that is 120 degree. 120 degree. Okay, 120 degree. So what is the displacement from A to B? If you know in such problems, that is, if you know the angle between the radius is given, so we can find the displacement using the formula. Displacement is equal to 2R sine theta by 2. Displacement is equal to 2R sine theta by 2. Here r is the radius of the circle and theta is the angle between these two radius vectors. Then x equal to 2 into r into, that is the radius of the circle, theta, that is 120. 120 by 2, that is sine 60. That's equal to 2 into r into sine 60, that is root 3 divided by 2. 2 get cancelled. That is root 3 r. That is the displacement. Okay, that is the displacement. How it is 2r sin theta by 2? Using vectors, we can prove it. That is 2r sin theta by 2. You consider this triangle. So, this is the origin of the circle. Okay, this is the origin. So, this is the radius vector. Okay, this is the radius vector. This is the another radius vector. And this is the displacement vector. Okay, displacement vector. So, if you draw the triangle separately, point here. So, R1, okay, R1, that is R2, okay, R2, then the displacement vector, okay, displacement vector, that is D. So this is a triangle, okay, this is a triangle where the three sides are represented by R1, R2 and D. R1 vector, R2 vector and D vector. So that we know the triangle of vectors in the next chapter we will study, that is a triangle of vectors. If two vectors represents the two adjacent sides of a triangle, okay, two adjacent sides of a triangle which are taken in the order, okay, which are taken in the order. The third side which is taken in the reverse order represents the resultant of these two vectors. If two vectors represents the two adjacent sides of a triangle which are taken in the order, the third side, the third vector which is taken in the reverse order represents the resultant of these two vectors. So here you listen, that is R1 vector and D vector which are in the same order, okay, taken in the order. Then the R2 vector which is taken in the reverse order, okay, reverse order. Here R2 represents the resultant of R1 and D vector. So according to triangle of vectors, from this diagram we can write, so R1 vector plus D vector is equal to R2 vector. So D vector is equal to, from this, that is R2 vector minus R1 vector. Okay, R1 vector. So D vector is equal to R2 vector plus minus of R1 vector. Again, the addition of two vectors. Okay, addition of two vectors. So we can use the triangle of vectors, that is the magnitude of D vector. So magnitude of D vector, that is D, is equal to square root of R1 square plus R2 square plus 2 into R1, 2 into minus of R1 into R2 cos theta. Theta is the angle between this R1 and R2. Okay. So that's equal to root of R1 square plus R2 square minus 2R1 R2 cos theta. Okay. So in our case, so we are taking that is R1 and R2. In our case, these two are same. That is taken as the same radius vector. So here this is also R. This is also R. Okay. So that's why square root of R square plus R square minus 2 R square cos theta. Okay, cos theta. So that's equal to 2R square minus 2R square cos theta. So that's equal to root of, take 2R square commonly outside, that is 1 minus cos theta. Okay, cos theta. In trigonometry, we have a relation that is 1 minus cos theta is equal to 2 sin square theta by 2. 1 minus cos theta is equal to 2 sin square theta by 2. So that's equal to root of 2r square. Instead of 1 minus cos theta, we can write that is 2 sin square theta by 2. So that's equal to root of 4r square sin square theta by 2. So when it come outside 4, that is 2, r square, that is r, sin square theta by 2 sin theta by 2. Okay. So this is the formula we used, that is 2r sin theta by 2. Okay, so that's the formula, that is a displacement vector. So displacement vector is equal to we can use the formula, that is 2r sin theta by 2. Okay, using vector method we can do it. That is 2r sin theta by 2. If any of the problem, that is like a circular problem, if you know the angle between these two radius, we can directly use this formula. That is 2r sin theta by 2. So in the previous cases also, that is we can use this formula, that is directly to find the displacement. We can use this formula. Okay. The previous cases, that is an object starts from here and this, that is 1/4 of the circle. Okay, 1/4 of the circle. This is the center of the circle. So this here, this is the displacement. So what is the angle? That is 90 degrees. So we can put that is 2r sin theta by 2. That's 2r sin 90 by 2, that is sin 45. That's equal to 2r sin 45, that is 1 by root 2. Okay, that is root 2 into root 2 r into divided by 1 by root 2. Root 2 get cancelled, that's equal to root 2 R is the answer. We can use the formula. So in the next case, so the object starts from here and reaches the point here. Okay, reaches the point here, A and B. Okay, this is the center. So this is R, this is R. Again, what is the displacement? This formula, that is 2R sine theta by 2. Okay, that's equal to 2 into R into sine. What is the angle between R and R? That is in the opposite direction. That is theta is equal to here, that is 180 degree. Okay, 180 degree. So 2 into R into sine 180, that is by 2, that is sine 90. So that's equal to 2 into R into sine 91. That's equal to 2R is the answer. So we got the same answer, 2R. So if we know the angle between the radius vectors, we can directly put this formula. Okay. So the next problem, P8, problem number 8. Okay. A circular wheel of radius R, a circular wheel of radius R is rolling on the road. Rolling on the road. Rolling on the road. Circular wheel of radius R is rolling on the road. At a particular instant, P is on the point. P is a point on the circle. Okay. What is the displacement of the point P in half rotation of the circle? Half rotation of the wheel. That is the question. So what is the displacement of the point P from here on half rotation of the wheel? Okay, half rotation of the wheel. So when this wheel, from this instant when the wheel rotates half. Okay. In half rotation means this point will go outside. So here. Okay. Here. Here. Okay. So we have to find the displacement of this P and this P. So what is the displacement of this point P on half rotation of the? So when this wheel rotates half, this point will come the top of the circle. So we have to find the displacement. So this is the when the wheel rotates half, how much distance it will travel? One complete revolution. This wheel rotates one complete revolution means it travels the distance of, yes, it is equal to the circumference of the circle, that is 2 pi r. 2 pi r. When this wheel rotates half, means it will travel the distance, that is, yes, pi r. So that means from this distance is, yes, pi r. Okay. So what is the distance? This is the distance, that is 2r. That is r radius. So this is the diameter of the circle, that is 2r. So this distance we know and this distance we know. This is the right angle triangle. So this is the displacement we have. We have to find. So P dash. So displacement equal to P dash. That's equal to square root of, say this is the hypotenuse. Okay, hypotenuse. So pi r square plus 2r square, right? 2r square. So that's equal to square root of pi square r square plus 4r square. Okay, that's equal to r square, this pi square, sorry, root of r square take commonly outside, that is pi square plus 4. So r, come on, r square means come outside, that is r pi square plus 4. This is the answer. So this is the displacement of the point P dash. Okay, P dash. So what is the direction of the displacement? What's the direction of the displacement? Because the displacement is a vector quantity. So what is the direction of the displacement? So we can't say that the distance and displacement is exactly the north direction or south direction we defined. It makes an angle theta with the horizontal. It makes an angle. It is at a particular angle. That is, we can't say it is exactly towards north, exactly towards south, or north, south, or east or west. We can't say. So it makes an angle theta. So how much angle it makes with the horizontal or the vertical? Okay. So theta we know. So here perpendicular we know and base we know. So definitely we can find, that is tan theta is equal to, formula tan theta is equal to perpendicular by base. So that is 2r divided by base, that is pi r. Okay. So r get cancelled, that's equal to 2 by pi. So theta is equal to tan inverse of 2 by. So this is the direction of the displacement. This is the direction of the displacement. Okay. The last question, very simple question. A particle starts from the origin, and it travels minus 20, 0 in the x-axis, 20, 0 in the x-axis, and returns back and returns back in the same line. Returns back in the same line and travels up to -20 comma 0. So this is the x-axis, x dash, this is y, and this is y dash. -20 comma 0. So what is the distance? What is the displacement? Okay, so distance equal to 20 up to this point, 20 again 20 plus 20. So distance equal to 20 plus 20 plus 20. So that's equal to 60 meter. Okay, so displacement equal to so from this point and to this point, that is 20 meter direction in the negative, in the minus x direction. Okay, 20 meter in the minus x direction. Okay, displacement is equal to 20 meter in the minus